So in this video, we'll be discussing how you can draw a tree diagram to show the sample space of an event. So you look up here for the definition. It says a tree diagram is a diagram that shows all possible outcomes of the event. And so you see you got this first example. Let's say you're flipping a coin twice. And so in that situation, when you flip the first coin, you have a choice of heads or tails. So this will be like your choices for your first flip here. You see I've drawn the root. Here are your choices. And it doesn't matter which one you put on top. So I'm going to put tails up here and heads down here. It'd be the same thing. Now, let's say you flipped that first coin and got a heads. When you go to flip the second coin, you still would have a choice of heads or tails. That's why you see it branched out here. If you flip the first coin and got tails, when you flip the second coin, you still have a choice of heads or tails. So that's how you go back in and make the continuing part of this tree diagram. So now from here, your first coin, let's say your first coin was head, and your your first flip on the coin was heads, and your second flip was heads. Your outcome would be heads on the first flip, heads on the second flip. This outcome here shows you heads on the first flip, tails on the second flip. This one over here shows you tails on the first flip, heads on the second flip. Notice these are different. This is heads first and tails second. And this one's tails first and heads second. And then finally, this is tails on both flips here. So you see you end up having 4 possible outcomes here. Now this one over here is when we had a face-to-face class. I would actually flip a coin and say what our outcome was and what the probability of the outcome was. So when it says what's the probability of your outcome, let's just pretend that we flipped a coin and we got heads and then tails. So in that scenario here, what's the probability you would get heads on the first flip, tails on the second flip? Come up here and look. You have 4 possible outcomes. That's your denominator. And the only one that has heads on the first flip and tails on the second flip is this one choice here. That's the only one that makes you happy. Have a total of 4 possibilities. So it would be 1/4 for your answer there. So like I said, that right there can change based off of your different tree diagrams that you may have. But for our tree diagram here, in this probability, this would be what our answer is 1/4. Now let's say we had this same scenario here, but instead of only flipping it 2 times, we're going to flip it once more for a total of 3 flips. So similar to here, let's say you had heads on the first flip, heads on the second flip. When you go to flip that coin a 3rd time, you still have a choice of heads or tails. Notice I've done that here. I basically took the other tree diagram that we had. Instead of having our outcomes, I've branched out heads or tails for the next choice, heads or tails for the next choice, heads or tails for the next choice, heads or tails for the next choice. So that's what ends up making the rest of this tree diagram down here. And then from here, just going back in, when I used to teach this, I used to say connect dots. So basically, just like we did in the first one, you're saying heads, heads, heads here, heads, heads, tails, heads, tails, heads, and so forth. So you see that's where we got all these different scenarios here. So in this situation, we now have 8 possible outcomes, whereas up here we only had 4 possible outcomes. Now we're at 8 possible outcomes. So let's say down here, we'll look at this piece here. It says, what's probably at least one of your flips was a heads. So you know you have 8 possible outcomes, 8 choices here, and you want at least 1 heads. So this one's okay, this one's okay, yep. So basically everything except for this last one here was tails for everything. So 7 choices would make you happy out of a total of 8. So that probability here would be 7/8. Now let's look at it from a different point of view. Let's go ahead and talk about a little bit of food. So over here it says you're ordering a pizza. You have a choice of thin crust or deep dish, and then a choice of mushrooms, pepperoni, or sausage. So draw a tree diagram that shows all the ways you can order a 1-topping pizza. So here you kind of think about categories you could set things up at. For example, the crust type is a category. Toppings would be a category. So I'm going to show you on the back of this paper how we could set this one up. Now, kind of put your categories up at the top in bold. I probably should maybe make that pizza crust instead of just pizza, because technically the whole thing is pizza. So here, if you're choosing the crust, you got a choice of thin crust or deep dish. And once again, it does not matter which one you put on top. You could put deep dish here and thin crust here. It'd be the same thing. All right, for your toppings, we have mushroom, pepperoni, sausage. Again, the order does not matter there. Down here, if you chose deep dish, you still have the choice of mushrooms, pepperoni, or sausage. So from here to get your outcomes, connecting the dots again, so thin crust mushroom, thin crust pepperoni, thin crust sausage. Same thing down here with the deep dish and these choices. So you have 6 possible outcomes. So it's your 6 ways to order a 1-topping pizza. Now, in that scenario, you actually could put the toppings first and the pizza second, or pizza crust type second, and it still would give you the same answer. So if you had these 3 first, you just have 2 prongs coming out of each one of these and have the thin crust deep dish, thin crust deep dish. So different ways you can write these tree diagrams here. And like I said, the nice thing about these is they show you all the different choices that you have. Now there is a shortcut that you could do rather than having to do a tree diagram. And I'll talk about that here in a little bit. Now when it comes to us trying to do some of these on our own, let's check out this paper here. I'm going to go back and show you, this is actually what it's talking about, the last tree diagram we made with the 3 coin flips. So this first one says, refer back to your class notes. If a coin is flipped 3 times, what is the probability we will get tails on the first flip, heads on the second flip, heads on the third flip? So if we go back up everyone, THH. So if I look at my different choices here, the only one that has THH was this choice here, out of a total of 8. So one choice makes me happy out of 8, so my answer here would be 1/8. Now let's get back into how we can draw a tree diagram here. Now I made this sheet a long time ago when my brother was in, I believe he was in 6th grade at the time. I was in college actually. And so a lot of stuff I made was based off of stuff that he liked at the time. You kind of see how old it is, because look right here, it's talking about a PlayStation 2 NFL game. I'm pretty sure nobody's using a PlayStation 2 right now, but you know, if you are, hey, props to you. It says you're building a football team in your PlayStation 2 NFL game, and you got to pick a quarterback and a running back. So your choices for quarterback are Favre and Peyton Manning, both of them are retired now. And your choices for running back are Damian Tomlinson and Priest Holmes, but them are retired now. So draw a tree diagram to display all the possible choices you have when choosing your starters. So when it comes to setting up this tree diagram here, what you can do is go back in and think about your choices. So you could choose either running back or quarterback first. It doesn't matter. I'm going to choose quarterback first. So here, it's kind of help me remember. You don't have to put it in this, but this can kind of help me remember. These are my categories: quarterback here, and then running back here. But you don't have to put those in there. Like I said, a lot of the ones I was drawing on the other paper didn't have that. All right, so my choice for quarterback would be Favre or Manning. There's my opening route. So if I chose Favre for my quarterback, I would have 2 choices for running back. I'd have Tomlinson or Holmes. So you've got Tomlinson here, Holmes here. Once again, the order does not matter. Down here, if I chose Manning, I still would have a choice of Tomlinson or Holmes for my quarterback. For my running back. Now, if I go back in and see what in my tree diagram was, in other words, all the possible outcomes, I draw my little arrows, and I connect the dots. So here I've got Favre Tomlinson. Here I've got Favre Holmes. Down here is Manning Tomlinson. And then Manning Holmes. So that's how you could draw your tree diagram for this situation here. Now look at this one on the bottom. This time we're drawing a tree diagram for different ways you can order a kids menu at Wendy's. Instead, you got the main courses are hamburgers and chicken tenders, and you can also get fries, baked potato, or oranges for your sides. So I'll put MC right here for main course. And I'll put S for sides. So for my main courses, like we talked about, hamburger or chicken tenders. Hamburger here, chicken tender here. Let's do that like this a little bit so you can see it. There's my opening route. I got 3 choices for sides, so when I come off of each one of these, I'm going to make 3 little prongs. And here you've got the choice of the fries, the potatoes, or the oranges. Same thing down here, fries, baked potato, and oranges. So now we go ahead and make our little arrows. So from here, connect the dots. This is hamburger fries, hamburger potato, hamburger oranges, chicken fries, chicken potato, chicken oranges. So in this scenario, we would have 6 choices. Now I told you I'd show you a shortcut on how to do some of these different outcomes without having to do a tree diagram. So maybe you get a question that doesn't want you to draw a tree diagram, just wants you to know how many possible outcomes. What you do is go back in, and for your categories, in other words, your main course and your sides, you can say, okay, I've got 2 main courses. I've got 3 sides. So you actually just multiply the amount of choices for each category and see how many outcomes you would have. So 2 times 3 will give me 6. So 6 possible outcomes here. Now it doesn't show you what the outcomes are if you do this shortcut. It only shows you, hey, you got 6 possible choices. So if you do the tree diagram, you get the advantage of actually seeing what the outcomes are. Same thing up here for our quarterback and running back situations. Here I could have 2, I'll draw down here, 2 possible choices for my quarterback, 2 for my running back. You could multiply that and see you have 4 possible outcomes. So that's your shortcut you could do with drawing tree diagrams. Rather than having to draw them, just ask you for how many outcomes, use that shortcut multiplication. All right. I want you to take a second. I'm going to put just like that. Put this up just a little bit further. There we go. All right. I want you to take a second and read over these questions here. Pause the video so that you can take time to read them, and then see if you can set up your tree diagrams with this. let's see how you did. So up here, you see I got my tree diagram drawn. I'm going to raise this up just a little bit more so we can see everything. Alright, so I got my tree diagrams drawn here. You see I put the pitchers first and then the catchers. Doesn't matter the order you put it in. But here you see I had 4 possible choices. And this one actually had an extra question. Said, what's the probability of signing Schilling and Rodriguez? So Schilling and Rodriguez would be this SR here. So that's where I got the 1/4 from. Down here, I got game 1. You've got 2 choices, the keeper and beater. Game 2, still 2 choices for each one of his original choices. So 4 possible choices in the end. And then finally, down here for our ECU football game, 2 choices for the first game. Off of that, 2 choices of the second game and 2 choices of the third game. So that's where those 8 possible outcomes will come from at the end. So the shortcuts I could have done for this would have been 2 choices for pitcher, 2 choices for catcher, 4 possible choices. Down here for the game, 2 positions in the first game, 2 positions in the second game, 4 possible choices at the end. And very lastly here, we've got 2 choices afternoon or night for the first game, same 2 choices second game, same 2 choices third game. Whoops. And that's going to be equals there to give you 8 possible choices. Just a little something on outcomes here and tree diagrams.